Hi there, I'm working on Module 2 in the second edition of Apologia Chemistry, and I'm working on your own 2.4 and 2.5, and they can be found on page 50. Before I get started talking about them, I'm going to just talk a little bit about heat. So the textbook defines heat for us at the beginning of this module on page 38. It says, heat is energy that is transferred as a consequence of temperature differences. So in other words, temperature and heat are not the same thing. Heat is something that is measured. We can measure the energy by the temperature differences, but the temperature differences themselves aren't heat. Heat is expressed in heat units, and the units for heat are joules or calories. The calories we're talking about are not the same calories for food. Those are 1/1000th of the calorie we're talking about. We're talking about what you would call kilocalories if you're talking about food, but in chemistry we just call them calories. So I hope that's not too confusing. We're going to use both joules and calories as units of heat, okay? So specific heat, as is defined on the bottom of page 49, is the amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. Okay? So it's going to be expressed in these units. Joules, which we said was a measure of energy per gram degree Celsius. Okay? So looking at table 2.1 and on your own 2.4. 2.4 says, and I'm going to correct the grammar of the question, which substance takes less energy to heat up, copper or glass? Well, copper's specific heat is 0.3851, and glass is 0.8372. So, remember, specific heat is the amount of heat necessary to raise the temperature of 1 gram of a substance by 1 degree Celsius. So this is the larger number, right? So this one takes more energy to heat up. So this is the answer. This is the substance that takes less energy to heat up. It has a lower specific heat. Okay. 2.5 says, a copper kettle and an iron kettle are placed side by side on a fire. After 3.0 minutes on the fire, the iron kettle reaches a temperature of 100 degrees Celsius. Will the copper kettle's temperature be higher or lower than 100 degrees Celsius? Well, let's look at copper and iron. So copper specific heat, as we said, was 0.3851. And iron, 0.4521. So what does this mean? This means that it takes more heat to raise iron, 1 gram of iron, 1 degree Celsius, than it takes to raise 1 gram of copper, 1 degree Celsius. That means that the copper kettle will actually be hotter, okay? Because the same amount of energy will make it hotter. It takes less energy for it to heat, therefore it will be hotter with the same amount of energy as the iron kettle. I hope this makes sense to you. If you have any questions, contact me. I always enjoy answering chemistry questions.